Hello everyone. So today we are going to start the paper discussion of JEE Part Test 2 Chemistry. I hope your examination went good. So let's start with the discussion. So this was your question number 1, which is asking to find the mole percentage of magnesium 26. What data is given? 79 mole percentage is for magnesium 24 and remaining whatever 21 percentage you have, that is magnesium 25 and magnesium 26. So they're asking to calculate the magnesium 26 isotope. So let's say percentage mole of magnesium 26 Bx. So if it is X, 25 isotope magnesium will be 21 minus X because the sum of both of them is 21. And magnesium 24 is 79. So these are the respective percentages given. Average atomic mass will be X, which is the percentage of magnesium 26 into 26 plus 21 minus X, which is the percentage of magnesium 25 into 25 plus 79, which is the percentage of magnesium 24 into 24 divided by 100 because overall it is 100%. And what is the data for average atomic mass? It is given as 24.31. So you can solve this equation, one variable, one question, right? And after solving this one, you will get X as 10. And what we have taken as X? Percentage mole of magnesium 26. So answer is 10. Now, let's go to question number third one. So what question number 3 is saying? What volume of 5N H2SO4 is required to neutralize a solution containing 2.50 gram of NaOH? So you know that H2SO4 is an acid, NaOH is a base. So equivalence concept we have to apply, right? So equivalence of H2SO4 is equal to equivalence of NaOH. So equivalence, you know, normality into volume for H2SO4 will be equal to, since mass is given for NaOH, we can use moles into X factor or N factor, whatever. What is the normality given for H2SO4? It is 5. Volume, I don't know, which I have to calculate. Moles, given mass by molar mass. So given mass is 2.50. Molar mass of NaOH you can calculate very easily. It is 23 plus 16 plus 1, which is 40. Yes, 40. Into X factor of NaOH. NaOH is it is going to furnish only one OH minus, so X factor is 1. After solving, you will get V. So you are going to get V as, so you are going to get in liter, but the options are in ml, right? So whatever V you are going to get, you have to multiply into 1000. So at the end of the day, you are going to get answer as 12.5 ml. Is that clear? So answer is option A. We can proceed to the next one. Okay. What does this question is saying? 5 mole of A and 6 mole of Z are mixed with sufficient amount. Okay, sufficient amount of C. That means C is sufficient to produce final product F. How many maximum moles of F can be produced as per the given sequence of reaction? Okay, so A plus 2Z give rise to B. How much moles of A we have taken? 5. Okay, initial is 5. Initial of Z is 6. And initial of this one is 0, right? So first we have to calculate the limiting reagent amount in this reaction. So 1 mole of A, right, reacts ideally with 2 moles of Z, right? I can change the markers to make you understand. 1 mole of A ideally reacts with 2 moles of Z. So 5 should ideally react with 10, but I don't have 10 moles. I have only 6 moles of Z. That means this is our limiting reagent. Now, according to the limiting reagent, the products get formed. So 2C gives 1B, right? 1 will give half, 6 will give 3 moles of B. So I got my B moles. Now, in the second reaction, B plus C give rise to Z plus F. B is how much? 3. C, it is sufficient amount of C. So C is excess reagent. So B is 3. It is something excess. This is initially 0, 0. So 1 mole of B produces 1 mole of F. So 3 moles of B is going to produce 3 moles of F. So 3 moles of F is the final answer. So answer is option C. So let's go to the next one. 54. M is the molecular weight of KMnO4. The equivalent weight of KMnO4 when it is converted to K2MnO4. Okay. So what is equivalent weight, everyone? So equivalent weight is molecular weight by N factor or X factor during the reaction. So MnO4 minus is going to MnO4 2 minus. So first, every element is balanced. Fine, that's good. Here 1 electron, here 2 electrons. So I have to add 1 electron over here. So X factor or N factor is 1. So molecular weight by 1, as simple. So it is one of the easiest question. So answer is M. We can go to the next one. Okay. Next one. If oxygen is present in 1 liter flask at a pressure of this much, then the number of oxygen molecules, okay, then the number of oxygen molecules they are asking in the flask at 0 degree C will be. Okay. So you know guys, ideal gas equation, PV is equal to nRT, where P is pressure, V is volume, N is number of moles, R is gas constant, T is temperature. So from here we can calculate number of moles, right? And from that one, we can calculate the number of molecules. So N will be PV is equal to PV by RT. What is P given? It is given in 7.6 into 10 to the power minus 10 mmHg. Okay. So it is given in mmHg. And you know that you can always convert this mmHg into ATM. And for doing that, you have to divide it by 760. So the pressure will be in ATM. Now volume is given. Yes, 1 liter. Fine. Divided by R value, you know, since I have taken the pressure in ATM, I have to put the R value as 0.082. And temperature, we have to take in Kelvin. So 0 degree C is 273 Kelvin. And after solving this, you will get your number of moles. So number of moles that you are going to get is, okay, so whatever moles you are going to get after solving this, then you have to find oxygen molecules, right? So you have to multiply. So moles you have got, and now you have to multiply with Avogadro's number Na, whose value is 6.022 into 10 to the power 23. After multiplying this one, you are going to get your number of molecules. And I have solved this one for you. At the end of the day, you are going to get your answer as 2.7 into 10 to the power 10 molecules of oxygen will be present. So this is the answer, and this is option A. So simple. So we can go to the next one. Okay. One more similar question, I guess. Yes, this is also much similar to the previous one. Here what is given? Pressure is given, right? So pressure is given as 1520 mmHg. Again, pressure is given in mmHg. So we have to convert this one into ATM. So we have to divide it by 760, and you are going to get in ATM. Volume is given. Yes, volume is also given. Volume is given as 5.6 liter. Temperature is given 273 degrees C. So you have to convert this one into Kelvin. So you have to just add 273 more, and that will be 546 Kelvin, I guess. Yes, correct. So number of molecules, again, you have to calculate number of moles. N is equal to PV by RT. So calculate this one. P, you can put 1520 by 760 into V, 5.6 divided by R, which is 0.082 into T, 546. So this is the number of moles that you are going to get. right? And you are going to get this value as 1 by 4. I have solved for this. So you are going to get 1 by 4. But what they have asked you is number of molecules. So number of molecules will be moles that you have calculated, which is 1 by 4, into you have to multiply this one with Avogadro's number, which is Na. So Na value, 6 into 10 to the power 23 divided by 4. This is the correct option. And this is the correct answer. Which option? It is answer B. As simple. Is that okay? So we can go to the next one. So next question. Okay. So, yes. So next question is, let me first read out this question. A gas mixture contains 2 moles of A, 3 moles of B, 5 moles of C, and 10 moles of D. If the partial pressure, okay, partial pressure is given. Partial pressure of C is given as 1.5 atm, and some moles are given. They have asked you to calculate total pressure. So everyone knows that Dalton's law of partial pressure. Dalton's law of partial pressure, that is we are going to use. So what does this say? So Dalton's law of partial pressure is partial pressure of a gas is mole fraction of that gas into total pressure, right? So it is for C we have to calculate. Yes, C partial pressure is given. So I can write this is partial pressure of C is equal to mole fraction of C into total pressure. So partial pressure of C is given as 1.5. Mole fraction of C will be moles of C, which is 5, divided by total number of moles, that is moles of A plus B plus C, 2 plus 3 plus 5 plus 10. Okay, D is also there. So yes. And total pressure, they have asked you to calculate. So 1.5 is equal to 5 divided by 20 into P total. So P total will be, it is 30 by 5, right? Yes, 30 by 5. 6. So 6 atm will be the total pressure. Option B. Yes. Next, we can go to the next one. Okay. 58. It is one of the questions from GOC or organic chemistry, you can say. Which of the following compounds is not chiral? Very simple. Which of the following is not chiral, right? So which of the following compounds is not chiral, right? So what is chiral? So an sp3 atom, it can be anything, not necessarily be to be carbon. Any sp3 atom attached with 4 different groups, we say that that is a chiral center. So see this option. Okay, there is some issue. Okay, it should be CH2. That is self-understood. Okay. So see this carbon is attached with this particular carbon is attached with 2 hydrogens, so it cannot be chiral. This carbon is also attached with 2 carbons, 2 similar hydrogens, not chiral. And this is also attached, this carbon is also attached with 2 hydrogens. So this is also not chiral. So in this molecule, there is no chiral center. And they have asked not chiral. So this is the answer. As simple. Next. Okay. A carbon compound has many functional groups. Okay. Polyfunctional groups it is talking about. Then the order of preference while naming it according to IUPAC nomenclature. Okay. Very simple. You know that carboxylic acid is prioritized first, right? In nomenclature system. So what are the groups? Let me see. We have carboxylic acid. Okay. We have aldehyde. We have NH2, which is amine, and we have OH, which is alcohol. So these are the 4 groups we have to compare, right? So what is the order, guys? So carboxylic acid is prioritized first. So carboxylic acid during nomenclature, followed by aldehyde, right? CHO, then followed by alcohol, OH, and then followed by amine, NH2. So this is the answer, and check for the option. It is option D, right? Yes, it is option D. We can go to the next one. The number of isomers in C4H10O. Okay, the number of isomers in C4H10O. Guys, we have always been told that whenever we have to calculate isomers, we should always calculate degree of unsaturation, because that is always going to give me the idea about how many pi bonds are present in the molecule and how many rings are present in the molecule, right? So calculate du first. So 2 into number of carbon minus hydrogen plus 2 divided by 2. This is the formula to calculate degree of unsaturation. And how much we are getting? Degree of unsaturation? 0. That means in this molecule, there is no pi bond. Pi bond is not present. and there is no ring. So you don't have to worry about pi bonds and ring. Now, so if I don't have to worry about pi bonds and ring, and it is an oxygen containing molecule, the first thing that comes to my mind is alcohols. So alcohol, right? We can make alcohols with this molecular formula. So let me first make the simplest of the simplest alcohol. This is the simplest alcohol, 4 groups, 4 carbons, OH. Now this is butyl group, right? 4 carbons. That means this is butyl group. Butyl group exists in 4 different things, right? N-butyl. So whatever I have done right now is N-butyl. You can make sec-butyl. OH over here. This is sec-butyl. You can also make isobutyl. And you can always make what? Tertiary butyl. So these are the 4 alcohols that you are going to get. Yes? Okay. This is alcohols. Whenever we talk about alcohols, we talk about one more functional isomer, which is ether. So what is ether? Oxygen in the middle, right? And we have to put R and R. So how many carbon atoms we have? 4. So what are the permutation combination you can make? 3 carbons on one side and 1 carbon on the other. And the other possibility is oxygen in the middle, 2 here, 2 here. These 2 ethers you can make. Now you see this is propyl group, right? This is propyl group. Propyl group can also exist in 2 different things. Right now what I have done is N-propyl. You can make it isopropyl as well. So these are the 3 ethers. So alcohol 4 and ethers 3. Total answers will be 7. But they have told isomers. I have always told you in the class, whenever they are telling about isomers, you will always consider stereochemistry as well. Right now what we have done is structural isomers. First check, is there any molecule which is chiral? Yes, we have one molecule which is chiral. Be very careful. This is chiral. Because this carbon will be attached with 4 different groups. Ethyl, methyl, OH, and one will be hydrogen. So this is chiral. So you are going to count this one as 2. So total 4 alcohols, 3 ethers, out of which 1 alcohol is chiral. So answer will be 8. We can go to the next one. Which of the following has the highest nucleophilicity? So what do you mean by nucleophilicity? The better, the best nucleophile among the following. See guys, here all are negatively charged species. First thing, okay. All the elements belong to the same period. Second thing. So you don't have to worry much about the size of the elements because they belong to the same period. So nucleophilicity is directly, you can find out with electronegativity, right? Here F minus, here O minus, here C minus, here N minus. Nucleophilicity, that means nucleophile, how easily you can donate electron pair. So the one which is the least electronegative among the following, there the electrons will be loosely bound and they can act like a best nucleophile. Among fluorine, oxygen, carbon, and nitrogen, carbon is the least electronegative element, so the best nucleophile among the following. Is that okay? Yes. Now we can go to the next one. The compound in which carbon uses only sp3 hybridized orbitals for bond formation. Okay, sp3. I can clearly see the answer. This is formic acid, right? So there will be one C double bond O. This is urea, right? In urea also there is C double bond O. This is aldehyde, right? There is C double bond O. And this is alcohol. So you can just open this molecule and write it. So sp3, carbon uses only sp3. So this is sp3, this is sp3, this is sp3, this is also sp3, right? So very simple. This is one of the question. I hope everyone has done this one. We can go to the next one. Okay. The next one, 0.24 gram of an organic compound gave this much carbon dioxide on complete combustion. Okay. It is an organic compound, fine. If it contains this much percentage hydrogen, then the percentage carbon and oxygen will be, okay, very easy. So you know that in carbon dioxide, it is CO2. The carbon in carbon dioxide has come from the organic compound. So in 44 gram of carbon dioxide, which is 1 mole, you have 12 gram carbon, right? In 44 gram of carbon dioxide, you have 12 gram carbon. So in 0.22 gram of carbon dioxide, how much will be the carbon? Just unitary method, right? So 12 by 44 into 0.22. This many carbon will be there, right? And percentage carbon will be mass of carbon that I have got, which is this one. Total mass of the organic compound, which is given 0.24 into 100. This will be the percentage carbon. Just you have to solve this one. Let me just solve this one for you. And after solving this one, what I am getting is 25%. So 25% is carbon in this organic compound. What is percentage hydrogen? Given 1.66 hydrogen. So 25% I have got for carbon. So two options eliminated. Oh no, okay, one option eliminated now. Now oxygen, percentage carbon and percentage oxygen. So it is an organic compound. Sum of percentage is always 100. So percentage oxygen will be 100 minus sum of percentage carbon and hydrogen, right? This is hydrogen. Okay. So 25 plus 1.66. How much you are getting? You are getting 73.4 percentage oxygen. So which is the correct option? 25 percentage carbon and 73.4 percentage oxygen. So answer is option B. Okay. So let's go to the next one. Okay. So redox couple, I think. No. Okay. The strongest oxidizing agent. Okay. So what data is given or what values are given? So this is a complex FeCN6. 4 minus is going to FeCN6 P minus plus electron, and E naught is given as minus 0.35 volt. So what does this negative E naught says? That this reaction is non-spontaneous and this reaction is not very favorable. But the other way around, this one going to this one, E naught will be plus 0.35. That means what I can say that here, this complex, this particular complex is interested or willing to go to the backward side as compared to the given one. So I can say that this is, what is the oxidation number of Fe over here? You can calculate. So this reaction is favorable. Now for second reaction, Fe plus 2 is going to Fe 3 plus electron. And here also E naught is given as minus 0.77 volt. That means Fe2 plus is not willing to go to Fe3 plus because E naught is negative. But the reverse way around, Fe3 plus is willing to go to Fe2 plus very easily because E naught will be plus 0.77 volt. Is that clear? That means Fe plus 3 is getting reduced and this reaction is favorable. So Fe plus 3 is getting reduced. That means Fe3 plus is behaving like a oxidizing agent. Here also I can say that this one is getting reduced, but the value of this one is more positive, so more spontaneous and more favorable. So the answer is Fe3 plus. Nice. So we can go to the next one. Okay. So one reaction is given. Okay, what is that reaction? Let me write it down. 2Cu2O, okay, plus Cu2S give rise to Cu plus SO2. I am not balancing, guys, because not necessary for this question. The oxidant and reductant respectively. So what is oxidant? Oxidant meaning oxidizing agent and reductant reducing agent, right? So first you calculate the oxidation number of copper over here. So oxygen is always -2, so copper will be +1 over here. Here it is sulfide, so here also copper is in +1. So in both the cases, copper is in +1 and it is going to copper 0. So in both the cases, copper +1 is getting reduced to copper 0. That means copper is getting reduced. That means these two are acting like a oxidizing agent. Oxidizing agent. Also known as oxidant. What about sulfur, guys? So sulfur here, it is present in sulfide as -2 and it is going to sulfur +4. So sulfur is getting, or sulfide is getting oxidized, right? So it is behaving like a reductant. So what I can say that copper +1 of Cu2O and Cu2S are oxidizing agent or oxidant, and sulfide is reductant or reducing agent. Check for the option. So this is the option, right? Option C. Yes, this is the answer. Easy. So we can go to the next one. Okay, which of the following are non-displacement, non-metal displacement reaction? Guys, very easy. And we have always told you that for chemistry, you have to always read NCERT textbook. This is one of the given in redox chapter, right? Non-metal displacement reaction. What they have given is usually the non-metal displacement reactions. The undergoing displacement is hydrogen. It can be oxygen as well, but the non-metal that is getting displaced is hydrogen. So just you have to check where hydrogen is getting displaced in the reaction. So here you see calcium plus 2H2O, hydrogen is getting produced, or hydrogen non-metal is getting displaced. Same thing over in option C as well, right? So answers are A and C. Check for the option. Is there any other option? No, I don't think so. So answer is A and C only. Clear? We can go to the next one. Okay. If stoichiometric amounts of KMnO4 and K2Cr2O7 mixture is added for the oxidation of Fe2 plus to Fe3 plus in acidic medium, then Fe2 plus will be oxidized. Yes, it will be oxidized. But what is the option? Equally by KMnO4 and K2Cr2, more by KMnO4 and more by, okay. So Fe2 plus is going to Fe3 plus because KMnO4 and K2Cr2O7 are oxidizing agents. Just balance the electrons. Okay, done. Now let's start with KMnO4. KMnO4, how does it is going to do the reaction in acidic medium? MnO4 minus is going to Mn2 plus, right? Balance this one. 4H2O, 8H plus, right? And you have to add 5 electron over here. Now, for the overall reaction, you have to multiply this one with 1 and this one with 5. So overall reaction that we are going to get is 5 Fe2 plus MnO4 minus plus 8H plus give rise to Mn2 plus 5 Fe3 plus 4H2O. Is that clear? Okay, this is the for KMnO4 wala case. Now, can we do for K2Cr2O7 wala case? Yes, we can do. So K2Cr2O7, Cr2O7 2 minus is going to go to Cr plus 3. Just balance this one, 2, right? Now you have to balance what oxygen. For that, we have to add water, 7H2O, 14H plus, and you have to add 6 electrons over here. So overall, with Fe2 plus, how does the reaction is going to look like? So what we have to multiply right now? We have to multiply 6 over here in this reaction. With K2Cr2O7, we have to multiply 6, right? So what will be the full reaction? 6 Fe2 plus, I'm not writing everything, plus Cr2O7 2 minus. I'm just leaving everything because I will get my answer by that only. Just I'm changing the marker. So see, 1 mole of MnO4 minus is oxidizing 5 moles of Fe2 plus. And here, 1 mole of Cr2O7 2 minus is oxidizing 6 moles of Fe2 plus. So which is more oxidizing? So it is Fe2 plus is getting more oxidized with K2Cr2O7. I hope that is clear. Yeah, nice. So we can go to the next one. Correct order of stability for what they are asking, correct order of stability among the 3 main conformations. Okay, conformational isomerism. Fine, very easy. Eclipsed, anti, and gauge of 2-chloroethanol. Okay, so there are 2 factors basically, torsional strain and van der Waals strain, right? These are the 2 main important factors which is going to govern the stability of these conformations, right? And you know that anti is more stable than gauge, is more stable than eclipsed. You always remember this one. But is this always true? No, it is not always true. Then what is the scenario? For this particular question, if I will have to make the gauge one, I'm just making this one. Okay. This is the general one. right, in general. But let me just make for this one. So 2-chloroethanol, let me just make it 2-chloroethanol, right? CH2OH, and here you have chlorine. So see this one, you can just make it like this. This, okay. This is OH. This is chlorine, right? And for this one, this is carbon. So H, right? Here you have H, and here you have H, which is Scotch. So generally, anti is more stable than Gauch, more stable than eclipsed. But what is the scenario over here? There is one thing that you have to notice. There is H bonding. So since there is H bonding, the order which you will be expecting to be this one will be incorrect. And the answer will be Gauch, the most stable, followed by anti, and eclipsed, these are not very stable. So this is the answer. So which is the correct option? Option C. Okay, so we can go to the next one. Okay, very easy. Tautomerism, right? Percentage enol content is 0. Okay, so generally keto forms are more stable than enol forms. Keto forms are generally more stable than enol forms, that you know. But let's say the enol form is aromatic. Let's say the enol form is aromatic. So in that scenarios, enol form will be more stable at equilibrium. But let me just see this question. Okay, this is very simple. You don't have to think so much. Just you have to check that option where enol form is not possible. That means there is no possibility to migrate hydrogen. There is no possibility to migrate hydrogen. See this one. I'm just making this molecule and your concept will be clear. CH3, 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 C double bond O, H. So this is alpha carbon, right? Alpha carbon must be sp3 with respect to aldehyde and ketone. And it should have at least one hydrogen for the migration. This is sp3, no doubt. This carbon is sp3. This is alpha carbon with respect to aldehyde. But there is no hydrogen to migrate. How you are going to make the corresponding enol? There is no enol. So the enol content is 0. As simple. So we can go to the next one. Okay. Next one is also from organic isomerism. Which of the following pairs of isomers is an example of, okay, metamerism? Nice one. Metamerism, right? So metamerism, what is the scenario? Ether, yes, ether, oxygen in the middle, right? And both sides R and R. Sulfur, thiol, sulfur in the middle, both sides R and R. And ketones, C double bond O, and both sides R and R. If both sides have different number of alkyl chains, then those two isomers will be termed as what? Metamers, right? So what is this one, guys? This is pentane, right? 1, 2, 3, 4, 5. So this is pentane, and this is neopentane. This is N-pentane and neopentane. So these are chain. Okay, what about this one? This is ketone group. I can clearly see this is aldehyde, right? So ketone and aldehyde, they are functional isomers. What about this one? This is alcohol over here. This is also alcohol over here. And these are positional, I guess. Yes, these are positional isomers. What about this one? Okay, nice. See this one is option D. In option D, okay, in option D, see, I'm just changing the marker. In option D, you might be thinking that, okay, let me do the nomenclature first. 1, 2, 3, right? 4, 5, 6, 7. Heptane, trione. And what about this one? 1, 2, 3, 4, 5, 6, 7. Heptane, 4-one. So you might be thinking that these are positional. But you must know the priority order in structural isomerism. First, ring chain, followed by tautomerism, then functional, then metamers, then chain, and finally you have positional. So if you are saying positional, It is correct. But I am saying metamerism. And metamerism will be more prioritized. And what you are doing? You are playing with the number of alkyl chains around C double bond O. Here, on the left hand side, you have 1, 2, 3, 4. 4 carbons and here 3. So it is C double bond O, 2 over here, 4 over here. What about this one? C double bond O, 1, 2, 3, 1, 2, 3, 3 and 3. You are playing with the size of the alkyl chain around C double bond O. So obviously these two are metamers of each other. So correct option is option D. We can go to the next one. Okay. The concentrated sulfuric acid, okay, 95% H2SO4 by weight. Okay. What does this mean? 95% H2SO4 by weight. So 95% H2SO4 by weight means 95 gram H2SO4 is present in 100 gram of solution. Clear? Okay. So what they are asked us to calculate molarity. Okay. Molarity, you know, molarity. Molarity is number of moles of solute by volume of solution in liter. Okay. So first we have to calculate this number of moles of solute. Solute is our H2SO4. So moles of H2SO4 you can calculate. Given mass by molar mass. Given mass is 95. Molar mass of H2SO4 is 98. You can easily calculate the number of moles, right? So what is the number of moles we can calculate? Just I am using one calculator to calculate this number of moles, right? So you can calculate the number of moles. So just I am using calculator. So what you are going to get is 0.9. So 0.969. So you have calculated your mole. So what else we require to calculate the molarity? We require volume of solution. So what is given? Any other data is given in the question? Yes, this is given. Density is given. So density of solution is given. So density of solution will be mass of solution by volume of solution divided by volume of solution. So what we require is volume of solution in liter, right? So density, what is given? 1.834 gram per centimeter cube, right? And mass of solution, here 100 gram of solution we have. So 100 divided by volume of solution, right? So volume of solution. So it is cm cube. So it is basically ml. So volume what we are going to get is, so volume whatever we are going to get is, we are going to get in ml. 100 divided by 1.834, right? And it will be in ml. So this is our volume, but we have to do the volume of the solution in liter. So we have to divide this one with 1000, right? Number of moles of solute. So 0.969 divided by volume of solution, 100 divided by 1.834. This is in ml. So just you have to do 1000 over here so that it is going to come in liter. And after solving this one, what answer we are going to get is 17.8 mole. So this is the answer. Is that okay? Yes. So we can go to the next one. So what is this question? The volume of 20 volume H2O2. So you should know what is the meaning of 20 volume H2O2. 20 volume H2O2. That means 1 liter, just one. So that means 1 liter of H2O2 is going to produce 20 liter of oxygen gas. That is the meaning. Okay. So 20 volume of H2O2. The volume of 20 volume H2O2 required to get 5 liters of oxygen at STP. Okay. So we are getting 5 liter. So 20 liter, just you have to apply unitary method. 20 liter of oxygen gas is produced from 1 liter H2O2. 5 liter of oxygen gas will be produced from 1 by 20 into 5, which is 5 by 20 liter H2O. but we have to calculate the answer in ml. So what we have got is in liter. So 5 by 20 into 1000. So this one. So what we are going to get, 500 by 2, 250 ml is the correct answer. Is that okay? Okay. We can go to the next one. Yes. Okay. The next one. Yes. What the question is asking for? Okay. The compound cyclizes to form one amide linkage. Okay. The number of optical isomers for the cyclic compound. Okay. So can you observe something over here in this molecule? Yes, we can observe something that there is lone pair over here, right? This is lone pair. This is deficient center and this is leaving group. And it is an acid derivative. You know that acid derivatives undergoes addition elimination reaction, right? So what it is going to do, this lone pair is going to attack to this center, this carbon center. This is going to shift up. Then it again it is going to return back and this chlorine will go out. And we are going to get a cyclic compound. And how does the cyclic compound is going to look like? This one, NH, okay. This one, this one, this one, right? C double bond O, and this one, right? This is what we are going to get. Is that okay? Okay. So what they have asked is the number of optical isomers. That means we have to check for chiral center. Is there any chiral center present? Yes, there is chiral center over here. Chiral center because it is attached with 4 different groups. One is methyl, one is H, one is this one, and one is this one. All the 4 are different. So this is chiral center. There is one chiral center. Is there any? No, there is no other chiral center. So there is one chiral center. So number of optical isomers will be. Is that okay? We can go to the next one. Okay. If the number of atoms of iron are this much, are there in 0.75 mole of iron is this much, then what is the value of P? Guys, there couldn't be any simpler question than this one. 1 mole have Avogadro's number of atoms, 6.022 into 10 to the power 23. How many moles you have? 0.75 mole. So how many number of atoms will be there for iron? 6.022 into 10 to the power 23 into 0.75. Solve this one. If you will solve this one, again, I'm going to use some calculator, but you shouldn't use. So what we are going to get as answer is 4.52 into 10 to the power 23 atoms. So you have to represent this one in the form of P into 10 to the power 23. So what is P? 4.52. But since we have to round it off to the nearest answer, right? Nearest integer of this one will be 5. Is that okay? We can go to the next one. The final question of the day. Okay, the final question of the day is the question related to titration. Okay, so what is the observation? First, read me the question. Consider titration of NaOH solution versus oxalic acid solution. Molarity is given. At the end point, following burette readings were obtained. Okay, 4.5 ml, 4.5 ml. Okay, guys, you can notice one thing that after 2 readings, the volume that I am getting is 4.4, 4.4, 4.4. That means equivalence point has been reached. So volume of NaOH I have got directly, which is 4.4 ml. Okay, so what is the question that they are asking? Then the molarity of NaOH. Okay, very easy. Equivalence of NaOH will be equal to equivalence of oxalic acid. What is the equivalence of NaOH? You can write molarity into N factor into volume. So you can write, yes, you can write N1V1 of this one is equal to N2V1. And since molarity is given, you can again write normality as molarity into X factor, right? Into V1 of NaOH must be equal to molarity into X factor into V2 of oxalic acid. Let me just put the values on the LHS side. Molarity of NaOH, I don't know, that we have to calculate. X factor of NaOH is 1 because it is going to furnish only one OH minus. Volume of NaOH we have calculated from the titration, which is 4.4 ml. What about oxalic acid? Molarity of oxalic acid given? Yes, it is given 1.25. What is the N factor of the X factor of oxalic acid? Oxalic acid is COOH. COH. So oxalic acid N factor is 2. And volume is given? Yes, volume of oxalic acid is also given, which is 10 ml, right? So it is also in ml, it is also in ml. Be careful with the units. So after solving this one, we will get the molarity directly for NaOH, and the answer that we are going to get is 5.68 capital M. So this is the answer that we are going to get. This is the molarity of NaOH. But we have to again round it off. So what is the nearest integer of 5.68? It is answer is 6. So 6 is the answer. Very easy. And this was our last question, and we got our answer as 6. So we are done with all the questions. I hope you are scoring good, you are practicing well, you are working hard. So that's all from my side. All the best for the second examination as well. Yes, thank you so much.